Right, out of the Z scores last night, which ones were a problem, if any? Or all of them? I don't like your face, Elfie. Oh, I like your face. I thought, I didn't know whether it was a sarcastic it was easy or a... Right, okay, yay. Anyone need me to do any one of them? What? What's wrong?
This is stuck onto my diary.
Oh no, it's not a math problem. That's okay. I can sort that. I can sort a math problem. Right, okay, now don't be intimidated by someone else saying it's easy. If you found one of them hard, tell me. We're all okay? Right, okay. The next ones, girls down here from 22 on, right, okay, they're not Z scores, so you have to turn them into a Z score first. They're X values, as in there was a survey. This is the number we got in a survey. We need to turn it into a Z score and then fix it. So I might see if... What? Why? Okay, girls. Shh. Thank you. Working backwards ones. Okay. Probably not connected.
Whenever that happens, though, I can't speak.
Okay, we're done with the talking, you're so loud. Right, please. Right. Write down the example where we're working backwards. So this time, I don't give you the Z score, I give you the probability and you tell me the Z score.
What's the title?
What's that?
What's the title?
We're still on Z scores and whatever, so it's example 2. Right? So this time, yeah, I think that bit, I think that should be actually I'm not sure the second sign is correct.
Excuse me, please. Could I have one student, one representative from Miss Hens, 5th year geography class to reception now, please?
That should be a greater than or equal to sign. The second one, sorry. Right, okay, so this time I'm giving you the probability and asking you for the z-score, right, okay, so all you have to do is scan, right, okay, this one's straightforward, right, so it's less than the z-score and the probability is 0.7374, so you scan the table to find 0.7374, okay, so 0.7374, I can find 0.7357, 0.7374.
It's 24. 7324.
Is it? Yeah, that's good.
It's at 062.
What is it?
0.62.
0.62? Yeah, so that means Z1 is equal to 0.62. As in, we found the probability that Z is less than or equal to 0.62. Is that okay?
This is from.
Sorry. No, it's magnified. Oh, yeah, it's magnified and frozen and everything. Bit like me. I'm not really this size, I'm magnified. I am frozen, it's really cold. And yeah, that's all recorded. Sorry, Kira. Right, okay. Is that alright? Are we okay with that? Working backwards. This one is a greater than, girls. Okay? So if you went to look for the table, you wouldn't find 0.1724 anyway. So what you do? Take it away from 1. So because it's a greater than, we take it away from 1 to find out what it originally was. Because remember, when it's a greater than, you get the original, you get the less than, and then you take it away from 1. So we take it away from 1 to find out what it was before that. So that's 0.8276. Would that be right? If anyone wants to, yeah. And then you go and you look and you see, can you find 0.8276? 0.8, or as near to it as you can get. 0.8264, 0.8289, yeah. Which one's nearer? It's about halfway between the two of those, isn't it? Would you agree? There's a 0.8264 and there's a 0.8289, and 0.8276 is about halfway between that. So I'd put an extra decimal point on it, and I'd say it's 0.945. Okay, is that right? Because it's kind of halfway between the values they give there. Okay, but you wouldn't be wrong for giving 0.94 or for giving 0.95. They wouldn't penalise you. Okay, is that right? Working backwards. We all happy working backwards?
Yes.
Right. Okay. Right. Example 3. Can I go? Example 3. Right. Instead of giving you the Z value, I'm giving you the value from the survey. Right. So there's been a survey. Right. Okay. From the survey, mu is equal to 300. What's that? What's mu? The mean is 300, right? Sigma is 25. What does sigma stand for? Standard deviation. And find the probability that x, which is the number of the survey, so 294. So 294 is the number of your survey. Okay, is that alright? Okay, so what do we need to do? We can only look up, if we want probability, what do we need? This is the only table we have that turns into probability. So what do we need to turn it into? Z-score, don't we? So we have a formula for Z-score. Yeah, sorry. Right, so we need to turn that into a Z-score, that X value, 294, into a z-score, because we can only look up z-scores on the table, not x, not random surveys. Okay, so we have a formula for a z-score. So x minus mu all over sigma. Okay, is that alright? So that's x is the value you're investigating, 294. Take away the mean, which is 300, divided by 25. Is that alright? We all okay? Will someone do that for me in the calculator? It's minus anyway, 6 over 25 minus 0.24. Yeah. So you now have a z-score. So instead of finding out the probability that x is greater than 294, you're going to find probability that your z-score is greater than or equal to 294 consists of minus 0.24. Is that right? Okay, so does everyone see what I've done? So this is what they gave me. I turned it into a z-score, and then you can change that x to a z greater than or equal to, because that's greater than or equal to whatever your z-score is. Okay, so quick diagram, right? Here's your mean in the middle. Minus 0.024 is here, right? Okay, and you want greater than that. So you want all that area there. Okay, but we can't do minus numbers, we can only do positive numbers. So let's do a positive 0.24. So let's do a positive 0.24, and basically that area there would correspond to what I'm looking for, wouldn't it? Okay, and that's the probability. So that would be the same as the probability that z is less than or equal to positive 0.24. Would you agree? Looking at the diagram, so you just look up 0.24, and you get 0.24.5948, 0.5948. Job done. Yeah? Is that okay? Do you want to do one of those for me, please? Before I move on to a next example, page 307, do number 23. So page 307, number 23 now, and then we move on to one with a story attached. Uh, 23. Yeah.
Do you convert that into a probability then?
Yeah, you just change, no, it's probability x is greater than or equal to 300. So you change that to probability z is greater than or equal to whatever you turn 300 into. Is that alright?
Yeah.
1.25 is it? Yeah, z is greater than, so that would be 1 minus less than 1.25. Yes.
Do you know when it's so do you know the last example you did? Can you just pick either when it's in the middle? Can you just pick any?
Sorry,
So
start again.
1.875.
1.875,
Yeah.
I'd round that up to 1.88. Yeah. I'd use the rules of rounding.
And what do you do when it's minus C then? You do it so...
Minus C, you have to draw it, what 175 ends up as being minus what?
Minus 1.875, so 1.88.
Minus 1.88.
Yeah.
Okay, so you want, what's the probability that Z is less than or equal to that, isn't it?
Yeah.
Okay, so I do a quick sketch so I can see it in my head. So the means in here, minus 1.88 is down here. Okay, and I want less than that.
Okay.
Okay, now, so that would be this.
In the question it says that x is greater than or equal to 175.
No, it says less than or equal to 175.
Does it?
Yeah.
Oh, sorry. Okay.
Is that alright?
Yeah.
Do you want me to keep going here?
So you just find
So the equivalent of 1.88, that would be the same as getting Z is greater than or equal to positive 1.88. That would be the...
So you just take the one.
Yeah, exactly. Yeah. Are we all good? Because that's more likely what you'll get. You won't get the Z score given to you. You'll get a results of a survey and you have to turn the survey result into a Z score to get the probability. Right? Okay, are we good? So that brings me to example 3, which has words on it, which is more likely what you'll see in a exam situation. Okay, so I'll leave you write it down first and then we figure out. Ready? No. Ready? Okay, yeah. Okay, right. It's no different to the ones you've just done. Okay, so to mind the words, get the mean, the standard. So the mean is 210, right? The standard deviation is 20, and then the first question: find the probability. So that's P, that the bulb selected at random will last more than 240 hours, so X is greater than or equal to 240. You want it more than 240 hours. Okay, so Z, turn it into a Z score. So it's 240 minus 210 divided by 20, which is 1.5, I think.
Yeah.
Right? So you want the probability that Z, so you're now turned it into a Z score, you keep whatever that sign is, greater than or equal to 1.5. So, quick sketch, I always do, I like a sketch. 1.5 is here, so you want greater than 1.5, so you want this bit here. Okay, so that's 1 minus the probability that Z is less than or equal to 1.5. Isn't that how we do the the greater than ones? So you look it up. 1.5, 1 is there, 1.5 is 0.8531. 8531, and that would be 0.1145. 0.469. Correct me if I'm wrong, please. I read the thing wrong, did I?
Yeah.
It's, what is it? 0.85.
0.9.
Yeah. Sure. Do you know what I looked up? 1.05 instead of 1.5. Idiot. 0.9332. 0.9. Or sorry, I'm not an idiot. I was just testing you. Right? 0.0568. Is that right? It's 6. I'm going to stop doing these in my head now because I'm not too old. Dementia is setting in. 0.668. Is that alright? Okay, happy with that? Right, the next one is part 2. Find the probability, so there's probability, that the ball would last less than or equal to 100. So you want, or less than or equal to 200. Okay, so it's the same thing again. You have to look up Z scores. It's the only table you have. So 200 minus 210 all over 20, and that would be minus 0.5. So you want to find the probability that the Z score is less than or equal to minus 0.5. Sorry, is that supposed to be 0.5? It is 0.5, isn't it?
Yeah.
Yeah, minus 0.5. Right, okay. Little sketch for myself. So I know minus 0.5 would be down here somewhere. 0.5. So I want less than that. So that would be the same as greater than positive 0.5. Wouldn't it? So that would be 1 take away the probability that Z is less than or equal to 0.5. Is that okay? So 0.5, I'll surely get it right. 0.6915? Yeah. So it's 1 minus 0.6915 equals 0.3085.
Yeah.
I'm nervous. Right, 0.3085. Is that alright? So just a story attached, girls, but there's nothing amazing in there. Right, okay, is that alright? So, and there's other ones in the book. I'll give you a few for homework. Right, well, do you want to do a story one before we move on to the next chapter? Right, we'll do a story one. Right, so if we do page 308, let's do 28, because I just did 27. So page 308, 28. And the formula for the Z score is in the log tables, okay?
Is the mean new?
Yes. For the third one, between 95 and 100. So it's, you know, it's the probability that X is between 95 and 100. So you turn 95 into a z-score, and you turn 100 into a z-score, and then you get like the ones you were doing last night with the between. Is that right? Will I leave it to you? Are those the z-scores you got?
Yeah.
Yeah.
Yes, you know when you get a minus z-score,
Yeah.
do you have to like change the more than or less than sign or something like that?
Yeah. You have to look at the diagram, and when it's over here you have to move to the equivalent area over here. That's why I always draw a diagram.
Okay. So the equivalent to greater than minus 0.6 would be less than.
Say that again.
So the equivalent to z is greater than or equal to minus 0.6. Would that be greater than 0.6?
No, it'd be less than 0.6 because it's the big area.
Yeah.
Okay, so when you put it over the other side, it has to be the big area, because greater than 0.6 is going to be the smaller area, isn't it?
And then you take that away from 1.
Yeah.
Yeah. Have you this one done, Alfie? Sorry? Okay. I want to know, did I mess up?
No, I got it.
You got that?
Calendar.
Sorry?
Is that the answer?
Yeah, to parts. The third part. Yeah, I think so, unless I've made a mistake.
No, that's at the back of the book.
Alright. Okay. I just put on the lights, it just got
Wouldn't the sign change like when you do from like -0.2 and then
yeah, and that's minus 1.2. And I said, right, we can only do the positive. So 0.2 will be here and 1.2 will be here. So the order changed as opposed to the sign changed. Do you know? So it's still between 0.2 and 1.2, but it's now between 0.2 is less than, 1.2 is the bigger number. Take away. Whereas in the other, when it was negative, the minus 0.2 was the bigger number. Is that right? So their order reversed as opposed to the signs reversing. Does that make sense? Like you wouldn't see that without a diagram. Okay, I can't emphasize how you need to draw diagrams, right? Because you need to see what you're doing. Do you? Yeah.
why I thought you had to take away one from, do you see
Which one?
part 3, the very first part when you're doing X is
95.
no the 100 part.
The 100 part.
Yeah, I thought you have to minus that from
Yeah. So no, you have to turn it into a Z-score.
I did, and I got 0.5793.
That no, it's minus 0.2. Well, it's 100.
No, the Z score is 0.5793 because it's the minus, so she
Yeah,
minus.
that's yeah. No. See, that's if you're dealing with that. Okay, so look, right, we agree on the minus 1.2 and the minus 0.2, right? The minus 1.2 is here, right? Okay, the minus 1.2 is here, and the minus 0.2 is here. So let's not get hung up on the taken away from one and the whatever. Let's just look, this is the area I'm trying to figure out. You would agree with that? It's between minus 0.2 and minus 1.2, right? Okay, would you agree? Okay, so then I can't do negatives. So I flip the thing over and I say, well, that's the same as between 0.2 and 1.2, right? Okay, so that would be, remember the chart gives you, so the chart will give you from 1.2 back, okay? So that's straight off the chart, okay? The other one is 0.2, that'll give you from 0.2 back, that's straight off the chart again, and you just subtract one from the other, okay? So I can't tell you the ones that are going to be 1 minus because it depends on what the question is. Is that alright? Yes.
You know, for part 2.
Part 2, yes.
Yeah. I minus it from 1, but the book didn't.
Right, so it's 98 centimetres or more, because I think it's going to be negative. Did you, when you get your Z-score, is it negative?
Yeah.
So when you did your Z-score, what is it, 98, take away 101 divided by 5,
Yeah.
right, okay, so that's
0.9.
minus 0.6, yeah?
Yeah.
Okay, so we want to know more, it's more than that, so we want Z to be greater than or equal to minus 0.6. Is that alright?
Yeah.
Okay, so let's draw minus 0. Right, there's the mean, minus 0.6 is down here, right? We want it to be greater than that. Okay, which is the big area, isn't it? Okay, so flip it, right? Okay, so we've a positive 0.6. So which part do we want, below it or above it? Below it, which is, we want the probability that Z is less than 0.6, which is just straight from the chart. Less than is straight from the chart.
Yeah.
Okay, is that right?
Okay.
So,
So you don't want to check, you don't want to minus it from one there.
yeah, no, you'd only minus it from 1 if you were looking for the small bit. If you were looking for that small bit, then if you were looking for that small area up there, you'd minus it from 1.
Yeah.
Right? So you have to ask yourself, am I looking for the big area or the small area?
Yeah.
And if it's the small area, you minus it from 1. But if it's the big area, that's what the thing tells you.
Okay.
Is that alright?
Yeah.
Okay. Right. Better? Worse? You all came in and told me Z scores were great, and now I'm looking at your faces and I'm worried I ruined everything. Right. Okay. So, girls, I'm going to introduce inferential statistics. I'm not going to do any sums on inferential statistics because I think we need to do some more Z scores and some of the revision exercises. But the reason I want to introduce it is there's a lot of writing. So I reckon if you write a bit today and write, you won't have to write as much tomorrow. So it'll give you a break from thinking if you're just writing. Yeah, is that alright? Okay, so I'll get you to write down the first few bits of the notes. Right, okay, and then we'll, inferential statistics, girls, is where it's all happening in the leaving cert. Right, okay, so the questions in the leaving cert, the Z score questions tend to come up in the short questions. The long questions tend to have inferential statistics. Right. Can anyone tell me inferential, infer? What does the word infer mean? Imply, like, isn't it? Right. Okay. So basically, what we're doing in this chapter is we're doing a little survey. Right, okay, so we survey 100 people, right, and we want to apply our survey to the whole of Ireland, okay, so we're looking at our little survey and we're seeing how far from the true value is my survey, right, okay, how far from the true value is my survey, is it in the ballpark, etc., and the calculations I have to do to get, you know, when I'm in or around, okay? So it's basically taking the results of the survey, and inferring it for the population. The population is everyone you want to know about, okay? So that's what inferential statistics is. There's a lot of words in here, right? And there's when it boils down to it, there's 3 formulas, right? Okay, going by the book, I don't like the way they do it in the book. There's like, they make it like there's 300 formulas, there's 3 formulas, okay? Right, okay. When you've collected data from a sample, that's the people you asked.
And you put the camera still
Oh,
on.
sorry, I was wondering why you weren't all writing frantically. And you're still not writing frantically because it's not working, okay. Join. Now we'll write frantically, right? Okay, so when you've collected data from a sample, so the sample are the people you asked in the survey, you use inferential statistics to understand the larger population. So you take your result and how do you apply it to the population from which the sample is taken. Inferential statistics has 2 main uses. So it makes estimates about the population. It's only an estimate, because the only way it can be completely accurate is if you ask every single person in the population, right? So it's an estimate, and testing hypothesis, right, to draw conclusions. That will be, a hypothesis would be, you know, the ad on the telly, that tell you about wrinkle creams. Now you probably don't watch ads because you're that generation that don't watch ads, but I still watch ads, and I'm also the generation that watches the ads about the creams that get rid of the wrinkles. None of them work, by the way. Right, okay, but you know, they tell you that 78% of women, it's always women, why? Men get wrinkles too. 78% of women, yeah, that's annoying actually. Why don't they get advertise wrinkle cream? Anyway, 78% of women, they make a claim. 78% of women said the cream worked. Said the cream got rid of all 7 wrinkles. Right, okay? Right, so that's a hypothesis, that's a claim that a company is making. So we can do a survey and test that hypothesis. So we'd go out and we'd survey lots of women, not men. We'd survey lots of women and we'd get our results and we'd compare our results to their claim, and we'd say their claim is false, or we'd say their claim is, it's okay, they can say that, right? Okay, so I don't know why I wanted to talk about wrinkle cream, and I'm just disappointed that nobody jumped in and said you don't use wrinkle cream. Yeah, but it's okay, you have Christmas tests that I have to mark, it's okay. Right, so this is what statistics is all about, because nobody cares about your little result from your little survey. It's all about the whole population. What can you tell me about the whole population? Everyone you're interested in, the whole of Laurel Hill, or the whole of Ireland, or whoever the hell you're talking about. Okay? So nobody's interested in your little survey, so you have to take your little survey, do lots of calculations on it, and then you can make estimates about the population. Right, and you could test claims that companies make, etc. Right, okay, that 95% of people love our biscuits. Maybe they do, maybe they don't. We'll do a survey and we'll prove you right or wrong. Right, are we okay? Mm-hmm. Is that written? Okay, I'll get you to write the next one and we'll stop then. Okay, this is why, it's really long. Right, these are just symbols that we're going to come across. A P by itself is a population proportion. That means a proportion is 27 out of 50 people said they love Miss Enright. Yeah, that's a lie. 49 out of 50 people said they love Miss Enright. And the person who said they didn't was her son. I have two sons, so at least one loves me. So population proportion, right, is 90 out of 100 people, 78 out of 100 people said whatever, okay? P hat is called, see, P with a little, I don't know, upside down V on top of it. That's called P hat. P hat is the sample proportion. That's what the survey says, okay? So population proportion is the actual proportion in the whole country who like this biscuit, and the P hat is what your survey said. It's a proportion what your survey said. So, right. Is that alright? N is the size of your sample, how many people you tested. You tested, you surveyed. Sigma is the standard deviation, we know this. Mu is the mean of the population, right? So it's the mean of the whole population. So that means you've had to ask everyone. X with a line across is the mean of a random sample, right? S is the standard deviation of a random sample, okay? So as we go through the chapter, there will be a difference, okay? So, but we're used to mu and sigma. They're the whole population, right? Okay. X with a line across is the mean of the sample, and S is the standard deviation of the sample, right? And a statistic is a measure that describes the sample, right? A parameter is a measure that describes the whole population. So the S's go together and the P's go together. So statistic is a sample, right? So statistic isn't true, right? Isn't accurate, it's an estimate. Whereas a parameter is true, it's an actual value, it's accurate. It's the whole population. Is that okay? Now, so we'll go page 308. We did 28, so let's do 29, 30, 31, and page 309. Okay, I just wanted to get a start on the writing because I don't want us writing all day tomorrow because there's lots of writing. Look at them lovely formulas, look at them. Yeah, there's only 3. There's only 3. What? No, you've only to learn bits of them. As in there's bits of them in the thing. It'll be, don't worry, it'll be fine. Right, okay, yeah. Listen, just think weaker people than you have done it, so, right, okay, yeah, just remember that. And passed, right, okay. So page 308, between now and tomorrow, 29, 30 and 31, so that's some more Z scores with a story, and page 309, 1 to 5 is some of the core exercises from the chapter. Okay, so because I think you've enough listening to me for the day, and that's where you all jump in and go. You know, okay, I'll do more.